Ladies and gentlemen, welcome to RPI Data Science YouTube channel. So today I would like to talk about quantile regression. One of my viewers asked me, I think a few weeks ago, one of my viewers asked me about making a video on quantile regression. I myself, I have never used this method, but it seems kind of very popular method in econometrics, maybe in also in environmental studies. But I haven't seen people using it in epidemiology or in healthcare research. So since I got this task from one of my viewers, I try to look what this quantile regression method is. It's not really very complicated method compared to other advanced methodologies, but it seems it's a good fit for some data. Let's say, in econometrics, if you want to visualize or if you want to model GDP versus life expectancy or those kind of things, or in this graph, for example, let's say I'm visualizing carbon dioxide emission as a function of GDP. So in this case, you see some of the points, it shows some kind of it's highly increasing as GDP increases. CO2 emission is increasing, but putting this line LM fit, that means ordinary least square regression or linear regression fit, doesn't seem to be actually fitting this data very well. So in this case, you may have to look additional alternatives. So what you're gonna do here is you try, let's say, quantile regression in this case. So what quantile regression differs from linear regression is, in linear regression, this is on the average, on the average value. So you try to average, let's say, if there are multiple points appearing on this side, so usually it appears on the middle, so it goes into the average. But in quantile regression, you don't take the average. Instead, you take quantiles or percentiles. So it's, let's say, how many percentage of the data points fall into 10% percentile. That's what you need to do. So what you do is you try to fit, let's say, the median value. So if you try to median, that means you fit a quantile value of 0.5, or if you want 90% quantile or 90 percentile, so that means you fit into 0.9, then probably this fits into a value which is more than the median. So let's say if you fit, this is how you plot it, but we will have a look at it in a different data set. So in this case, I'm using like plot CO2 as a function of GDP, and I'm giving it into my data, and then finally you see how this line looks like. Let's say if I'm running this, this would be a simple linear regression. So this is how it looks like. But if I add a quantile, that means a median quantile, the only thing I need to change is I have to add this tau value of 0.5, and then I need to add this instead of LM, I need to use RQ, and that means this quantile regression. It's coming from the Quantile package. I advise to look at the details of this package, the documentation. There is a detailed documentation in this package. So I use RQ and then data. Now let me have a look how the median looks like. So this is how it looks like. You see, it's a little bit higher than the mean. That means ordinary least square regression, but it seems closer. But that means it's not also, again, a good fit because it's not catching the data points. But if I'm using another one, the 10% percentile, which means it will fall underneath this. So if I'm using data points below 10% percentile, so now I will have another line and I will represent it with, let's say, with a black. So it's falling again in this side, and it's getting some of the points, which is a good sign, and it's also getting some of the points here, but most of the points are not falling here. But again, I need to try another one, which means again I need to add another upline. So that means again I will just change this tau value so that I can catch 90% of the data below the 90%. So if I run it again, now you can see the green line seems to be the best fit. But again, this is not proved yet whether this is the best fit. But you see multiple data points are captured by this line. But what you need is you need to make a loop of regression, and then you have to try number of values between, let's say, 0.01 and then 0.99, because it's a percentile, so it should be less than 1, of course. So it's between 0.01 or 0.99, and then you try multiple values and you see which quantile regression actually fits your data, and that's determined by your loss function. And your loss function could be mean absolute deviation or mean absolute error, and so on. Or once you fit your regression and you calculate your residual values. I'm not going into the details of this intuition, but I'm not going to use this data. So for that, I will just simply create a new SOS notebook, and then we will try to use a different data set. So what we will use is we will fit quantile regression by different tau values, by different percentiles, and then finally we will do a plotting which looks like this. So we will use Plotly, and in the end we kind of will have kind of fancy plots. But if you want, you can also have the documentation of the package. This Quantile package, they have a detailed documentation, so you may have a look. If you found this channel very helpful, or if you find the content of this channel useful, I would be very happy if you can subscribe, like, and share to your friends. So let me proceed straight to our today's video. So what I first need to do is I need to load multiple libraries. Let me just use Pacman library, Pacman, and okay, let me change this to R. Then let me add few kernels, few lines of code, this few lines, and finally let me load this library. And then once I have Pacman, I can use this payload. Then I can load multiple packages instead of writing library ggplot2 library in multiple lines. I can simply use payload and write like multiple packages. So I use dplyr for simple data manipulation maybe, and I can use janitor for cleaning up my variable names, and then ggplot2 for awesome plotting, and maybe I can use Plotly because I would like to use 3D plotting to visualize my regression, and then Quantreg. I think that should be enough. Then now I simply run this and everything should be loaded. This seems to be oh yeah, deploy. Yeah, now everything is loaded. Okay, let me read the data. This data is a life expectancy data. I have also used it in my previous tutorial, so you can simply read CSV, and let me use life expectancy. It's detecting it, thankfully. Now I can have a look how my data looks like, life expectancy, and life expectancy. Okay. this is how it looks like. I will not go into the details, but this is how my data looks like. I have life expectancy variable as a dependent. I will take this as a dependent variable, and I have like, you know, other variables like GDP, income index, and the like. I will just quickly proceed into the data wrangling procedures. I will not go into the details. Then finally I will just come back to my quantile regression topic. So you see now I'm cleaning up the variables, because I really don't like when the variable names appear like this, you know, like a dot separation, and if the variables names are written in capital letters. So I just use this clean name, and all my variables are cleaned. Now let me remove with one line. Let me remove all the missing values, and I can simply use this complete case. And let me have a look, the dimension of my data. So I have like 1649 observations and 22 variables. And let me just also replace one of my variable into income index. That's my independent variable. So I'm just replacing that. And again, let me remove some of the, let me just use income index greater than 0, because in my previous tutorial, if you remember, this data, this income value has so many 0 values, which means actually to be supposed to be missing. So I'm just cleaning up. And now let me show you how the data is related, how data looks like in ggplot2. So let me use this LM function. So you see the how it looks like, you know, a life expectancy as a function of index, income index, and that's status. That means developed and developing countries. So there is a linear trend that as income index increases, life expectancy increases, of course. So this is one sign, but this is, you know, this regression line is again using the mean. So it's a mean regression line using the linear model. But we need to try quantile regression. Of course, you need to make sure this data actually best fits with linear regression. If linear regression best fits this data, then you don't need to worry about quantile regression. But if it doesn't, then you may have to try things like quantile regression or any other method. I'm just using this for demonstration purpose. Otherwise, you're gonna try multiple different methods, and you try which one actually has a desirable loss function value. So you take the loss function, you compare, you try multiple methods, and then finally what you need to do is you compare them, and you choose the the regression choice that has a minimum deviation, or minimum absolute deviation, or mean square error, you know, the minimum square error. That will be your best regression. So let me plot life expectancy as a function of income index. So I will just reproduce the ggplot2 code with some base R, and it looks like this. So if I add something, so that means I will add upline, which means so to add upline, I can simply copy this actually, because I have already so upline LM life expectancy as a function of income index and data, that means life expectancy, and let me color it into blue, and let me make the line a little bit thicker so that we can see it. So this is again similar to what we have, but if I want, I can add the quantile regression. For the quantile regression, again, as I said, you can use this RQ and then upline. So life expectancy as a function of income index, and the tau value 0.5, which means the median. So the median quantile regression, and data will be life expectancy, and color I'm assigning it as red, and the line width can be a little bit bigger than the previous one. So you see, they are almost meeting. At some point they are meeting, but here they look somehow far away from each other. And to do another sign, let me another regression line, and let me use this 0.1. I don't need to change anything, I just need to change this, and I can run. Let me change the color into maybe black and run it again. So this is again, it will look like this is how it looks like. And again, let me try another one. Let me add another one. So that means now I can use 0.9, for example, or 0.99, 0.95, let's say. And let me make this one, let's say, turquoise. Maybe that's a nice color. I like that color. Unless I made a mistake. Yeah, okay. So this would be the 95th percentile, but that means you need to try multiple quantile values and at the end compare the mean absolute error or the mean square error, and then you decide which which regression fit has the lowest loss function value. That's how you decide. Now let me try again multiple different ordinary least square values. Multiple multiple quantile regression. Let's say in the first one, let me use ordinary least square method, and for that, what I can do is LM, so life expectancy, or you can also use RQ as it is, because if you don't simply let's say if you don't simply give the value, this that means it's linear model. So that means it's linear model. If I just use RQ like this, and it should be similar with the ordinary least square method. So you can also use LM, it's fine, but means if you don't define the, let me call this ordinary least square method, then the next one, let me call it quant reg median, let's say quant median, quant med, let's say, and then what I'm going to do here is I can copy this, and again, once here, now I can define my tau value, and the tau value should be 0.5 if you are running the median, the 50 percentile. Extra tau will be disregarded. Okay, LM tau 0.5. Let me just use RQ. In LM fit offset singular. Okay. Income index, data, life expectancy, income index. It should be working. OLS. Let me check the summary. It's actually it. Yeah, so we already have the value, so we don't need to worry about the error message. That's the median, and if I want, let's say, let me try again the 10 percentile, and again, let me try again the 95th percentile, 95th percentile, and then after that I can simply summary. This is not median, this is first quartile. First quartile. This one is 19th percentile, or last. You call it last. Now let me run all of this, and again, now I can simply call summary, and then check all of these values. Let's say in the first one, summary OLS. Then the second one, okay, let me just type them again. I have 4 different regression values. First one is QMed, that means median quantile regression. The second one was first, first, second, third one is last. Now if I look at the summary of these values, so I have different coefficients. So you see in the first one the estimate is 47, and the standard error is 0.8. That's the median. No, that's the ordinary least square regression. But if you look at the second one, it looks like the coefficient is high, but the standard error is low. So that means the linear model is not the estimates. You see the standard error is very high, so the confidence interval will be wider. So that means the median is actually better fit than this one. Again, you have to look at the third again. Again here 0.75 is getting bad because this is the smallest. No, 7591, 75. They are the same, basically the same, and here again they are the same. And then on the last one, they are also the same, so they are not very different, but still what you need to try is you try multiple different values, many different values, and then you see which one actually fits your data very well. So that's what you need. The last one, let me do this. So let me in this case I take a sequence of values from 0.05 to 0.95, and they are jumping every 0.005. So the first one is 0.05, the second one would be 0.05 plus 0.05, which means 0.01. The second one would be 0.015. Then it goes on and on, and that will take, I think it's about 19 different tau values. But you can use as much as you want, depending on how the initial and the last value looks like. That's what you need to. So let me run this, and then the rest is similar. You just use this quantile regression and the dependent variable as a function of your independent variable, and you define your tau values because we already assigned taus. So that means it's taking it into assigning multiple values, and it gives you a number of values for tau. Then you will have multiple regression equations. So you will have a lot of regression estimates. So let me run this, and I will show you a summary of this. So that means we will have 19 different regressions, 19 different quantile regression values for this. So Quantile, let me call this actually here, and if I run this, I will see 19 different regression values. So it's your to have a look. It's your you can have a look all of them and decide which one actually fits your data very well. So that's what you need to do. So you have multiple regression values. So that means we have about 19 different regression estimation, and then you decide which one fits your data. I will not go into choosing the right quantile regression model. What I'm going to show here is how you need to define it, and then finally how you will visualize it. So let's say if I want to extract all the coefficients, what I need is I need to use this coefficient. Otherwise, you can also use you can also use names, and you can check. So we have many different names for the model. We have the coefficient, we have the x and the y, the residual values, and so on. So if you just use something like this, and if you just use this $sign and coefficients, you will have access to all the coefficients. So that means I have all the coefficient values. That means for each tau value, I have different estimates. So that means this is the beta coefficients for each tau value between 0.05 and at the end I have this 0.95. Otherwise you can also use this. So simply you can use this QR Conf and Quantile. That's the model that we have defined above. And let me just use run it again. I should have the same result. So again, it's the same. So it's your choice. That's how you access the coefficients, but we will need more. I think for that I will have to create a function. Let me add a few more lines. So for that I will have to add a loop that goes through each tau value, and it goes through over and over again, and it multiplies many different tau values and calculate estimate the regression equations. So for that I will need this quant loop. That means quantile regression in a loop. So I will create a function that will take this x, y, h and 19 different, because I'm using from 0.05, 0.5 to 0.95 with 0.05 jumping. You know, it will jump the sequence of values between 0.05 and 0.95. So I'm using this function. For that I will assign xx, and then the sequence will be the mean value of x and the max, and the length will be m. That means m that I assigned above. And then I will give the factor variable and the dependent variable, and then finally I will run the quantile regression in a loop, which means I will use the for loop for I in one in length xx, which is my factor variable, and then I will do a z, and I will do this d norm because I want to calculate the quantiles. Then finally you can use this to run, because this is the same equation actually that we have used above. So to do that, you just define your R, that's a regression, so that means RQ. And then once you have that, you define your coefficients. For the first one should be for the intercept, and the second one should be for the dependent variable, because if you remember, we have estimates for no, it was here. So let me run this again, and I will show you we have two coefficients actually, one for the estimate, one for the dependent variable, and then the intercept. So the first one is for the intercept. The second one would be for the variable income index. So I will run this, and we'll still need more. So let me again define taus, maybe, because it might be needed. So let me use this sequence. So for that I will use sequence, and from 0.05 to equals, so that means from 2.95 by, that means how much is it jumping, so by 0.05. So let me use this. So once I have that, let me again QQR, let me define this QQR coefficient, and then can simply assign this into as a data frame. So this one will create a data frame of the 19 a data frame and a matrix. So let me just use the data frame, then matrix, then maybe from 0 until n equal 19, because I want to create a 19 by 19 matrix. This should be n row. N row should be 19. So I can run this and see, oh, here I made a mistake. So let me run this again. Could not function matrix. I made a typo, and now it should be possible. now if I look at this, it should be all zeros, you know, because I already assigned 0. So it's a matrix of all zeros, but between the column is 19 and the row is 19. So it's so if I run this, you will have all of these values. Now I need to I will have to replace them with you know, with that regression equation once I run this function in my loop. If I run my regression, so that would be, they would be replaced. So for that, what I need is, let me, to make it simple, let me define my outcome variable, which is life expectancy. Life expectancy in a RM, that's my dependent variable, and life expectancy. And then my dependent variable or predictor, let me call it life expectancy in a RM, and then income index. So let me use this. And then once I define that, I can simply run my function, the function that I create, this quant loop. Then I can run it in a loop. So to do that, I can use this actually for loop again, for I in 1 to 19, because I have 19 different, you know, different values. I mean, there's 19 different rows and columns. So from 1 to 19, actually from for the rows, from 1 for row 1, row 2, row 3, and then from 1 to 19. So then again, what I need is, I need to define my regression. So what I can use is, I can call my quant loop function, and I can call my outcome variable and the predictor, and the jump 0.05, that's the quantile values that I need, and then the tau would be taus. Already have taus, I think, here. But what I need is, it's not only the taus, I need to define this this I, because that's for each tau value that it needs to run. Then what I need is, I need to define this this QQR, because I want to replace this. If you see, all of them are 0. So for that, what I need is, I need to call this QQR coefficients I. That means actually the columns would be X, should be taken from X, yeah, from the quantile regression. So let me run this again and have a look. So there seems some error. Let me have a look. So our income index, OP, taus, and QQR coefficient. Oh, this one, this I should not be there. I made a mistake. So now it should be done. So if I run this, you will see all of these coefficients. I mean, all of these values, all of these zeros should be replaced by my regression estimates. So this is how it looks like. You see all of multiple different estimates that I have for this quantile regression values between 0.05 and 0.95, and separated by, you know, this 0.05. Now what I need is, I need to visualize this regression. So for that, what I need is, I need Quantile. Let me load, but I already loaded it with Pacman, so I don't need to load it. So, but let me extract my beta values. So for that, I can use as matrix, and actually they are already there. They are already as matrix, so I don't need to do anything like that. So what I need is, I need to yeah, okay, let me check QQR coefficient. Okay, QQR curve. So let me just give beta. That means beta should be all of these. Yeah, and if I run this, it should be replaced immediately. Now after that, you have to check Plotly, Plotly surface plot, Plotly surface plots. I think that's what you need in R. So they have everything what you need. So I don't have to go through all. But it seems some of my browser is not running it. But we will see. Let me hope that it will run. So let me use Plotly, plot ly actually, plot ly, and then z value, because I need x, y, and z axis. The z axis should be beta, and the x should be all the tau values, taus, and again the y axis should be again all the taus, because I'm using the same tau value for the x and the y values, so they should be taus. Maybe I can define the opacity into the default 0.6, 0.6, 0.5, doesn't matter, and then finally I can pipe it, then I can add markers. So once I define that, I can add the P, that means my plot, and add surface, so because I need the surface plots, then Z, then I can, Z is my beta, X is again the taus. I will just use again all of them here and add additional arguments, let's say show scale, show values, and the like. Show scale, show scale. Oh, I made a mistake here. I don't need another comma. Show scale. It should be show scale, I think. Show scale equals true, because I want to show the scale. That means the legend. And then finally I can add the layout, show legend. I don't need to add show legend. Legend equals false. Let me assign it false. Now let me hope that my browser will be able to run it, and let me see. That must be a numeric matrix. Okay. Let me put this as matrix just in case. But it's already a matrix. Let me try. Bingo, it's trying it. It's probably working. Wow, this is great. It's working. So this is how it looks like. So it's kind of fancy plot. So you see the beta, the quantiles of x and the quantiles of y, and then this is visualizing the quantiles of x and the quantiles of y, again with beta values. So you see the beta values are on this side. So you have from minus something until 1, and then you see how they look like. So it's I think many people use this MATLAB to produce this kind of plots, but I think with Plotly it's even nicer. So this is how you would visualize this quantile regression in R. Looks nice, but I think it's I to be honest, I don't really have much knowledge of this quantile regression, but I just tried it, and let me know your feedback. If you like it, I can also share you my code, and then you can use it for your own analysis. Thank you. I hope you find this content very helpful, and please subscribe. Thank you. Okay. Let me pause it.